Starting first law of thermodynamics, I want to discuss few very simple things which are very common. You can see that one or more than one correct. There are few questions asked and they are very simple. So the first question is, among the following, the state function is R. So what is the difference between a state function and path function? State function is the property of the system. जैसे अगर मैं if I talk about myself, I have two hands and two legs, right? And this is along with me at any time, any position, right? So similarly, we can say that state variables are those variables of the system which are present at any state of the system, right? जैसे internal energy can be less or can be more, but it is always there in the system. So internal energy is a state variable. When we are talking about work, suppose if I am present at initial state A, there is no meaning of work at this state. When I move from A to some other state B, the path followed by me, the work depend upon the path followed by me, right? Either it is reversible path or irreversible path. So work done, either it is reversible or irreversible, it is a path variable, right? So this could not be a state variable. Work reversible as well as work irreversible is a path variable. Molar enthalpy or enthalpy is the property of the system, right? So enthalpy at any state can be H1 and enthalpy can another state will be H2. So molar enthalpy means the number of moles of the substance will be 1, but it is again a state variable, right? So these are a state variable. If we talk about path variable, there are three variables which are path. The one is work, other is heat energy exchange between system and surrounding, and the other is heat capacity. Like, because we are saying that heat capacity at constant pressure will be different from heat capacity at constant volume. So if the path is such that the pressure is constant, heat capacity will be Cp. If volume is constant, then heat capacity will be Cv. Along with that, I want to discuss that delta H is H is a state variable. H is a state variable. But delta H is not a state variable, because in order to define delta H, we need two states. H delta H को define करेंगे तो H2 और H1 will be there. So H is a state variable, but delta H is neither a state variable nor a path variable. This is neither state variable nor path variable, because in order to define that delta H, we need two state. It is not defined at a particular state. That's why it is not a state variable. And it is not a path variable because delta H depends on the initial and final state. It does not depend on path. So this is about the first question. So this is the answer given by J Advanced. The second question is, among the following, the intensive property or properties are. So intensive and extensive. We know that intensive property does not depend on the amount of the substance, and extensive property depends. So suppose we have taken an electrolytic solution, the molar conductivity of this solution, either I take 1 liter of the solution or if I take some ml of the solution from this, if the molar conductivity of this solution will be lambda m, for this solution also molar conductivity will be same. So molar conductivity is an intensive variable. EMF of the cell, because we know that when we are using Nernst equation, EMF of the cell is equal to E naught of the cell minus 2.303 RT upon NF log. यहाँ पे reaction quotient में again concentration terms. So temperature is intensive variable, right? Here if we discuss about this EMF is intensive variable, right? If I take a cell, the amount of solution if I change, but if I keep the concentration same, EMF is not going to vary. But delta G, we know that delta G is minus NF EMF of the cell. So delta G is extensive variable, but EMF is intensive variable. Resistance, you know, it depends on the length. So it is an extensive variable, and heat capacity is an extensive variable. Again here, when we are talking about intensive and extensive variable, suppose an extensive variable is there, and if I divide the extensive variable by total moles of the system, like internal energy is there, which is an extensive variable. If I divide by total mole, it is molar internal energy. So molar internal energy will become an intensive variable. This is an intensive variable. Similarly, we know that density is mass by volume. This is mass. Mass is an extensive variable. If I divide the mass of the system by total volume of the system, it will become density. So density become intensive variable. So dividing an extensive variable by total moles or total volume, right? Or heat capacity is an extensive variable. If I divide by total mass of the system, this become intensive variable because it becomes specific heat capacity, which is an intensive variable, right? So if we divide the extensive variable by total moles or total volume or total mass of the system, the extensive variable will become intensive variable, right? So these are very simple questions, but you should be very careful about them. So coming to the first law of thermodynamics, we know that first law of thermodynamics means law of conservation of energy, and there is no theoretical proof of first law of thermodynamics. It is derived from experiment. Until now, it is valid for all type of system. We know the mathematical form of first law of thermodynamics. We are writing that delta E is equal to Q plus W. So this is mathematical form, and this is according to IUPAC convention. So ये chemistry में हम IUPAC convention use करते हैं. We'll discuss that what is the difference between physics and chemistry, and you should not be worried about, because the final result from physics and chemistry will come same, but the conventions are different here. Here delta E is change in total energy of the system. Q is exchange of heat energy between system and surrounding, and work done is exchange of heat energy between system and surrounding. Anything which increase the total energy of the system. Suppose if I am giving heat, this is the system, I am giving heat energy of to the system, then the total energy of the system is going to increase. Anything which will increase the total energy of the system has positive sign. Anything which decrease the total energy of the system. Suppose the system is a gas with cylinder and the system is doing work. So because of the surrounding, when this piston will move, the system is going to lose energy. So we'll say that anything which will decrease the total energy of the system should have negative sign. So the sign positive and negative is very clear according to IUPAC convention, right? So when we are writing this first law of thermodynamics, right, we should be very careful about writing the work, right? Whenever we are going to write the work is the path variable. That's why generally हम ऐसा लिख देते हैं, but path variable are not exact differential. We should not write like this. We should write like this. This is the right way. Roughly we write like this. So whenever we are going to write the work done, we should write minus times of P external into dV, because here the external pressure, external factor will decide that the system will do work or not. Suppose there is vacuum, then P external will be 0. And if there is expansion, then also the system is not going to do any work. So this convention is correct, right? When you study physics, in physics you are writing that work like this. So this is pressure of the system and this is volume change of the system, right? But suppose if this is the European convention, and in this there is a problem, like we cannot define free expansion. According to free expansion, suppose if I am saying that this is a gas and there is a pressure of this gas, और बाहर जो है वो P external 0, P external 0 वैक्यूम है. So according to physics, if I am saying that this is the pressure of the gas and this is the volume change, in expansion volume change will be positive, pressure of the system will be positive. So in free expansion, according to physics, work should be positive, means work is done by the system. But actually, if you see IUPAC convention, this is more accurate, because if P external will be 0, if there is vacuum and we are expanding, then there is no work done. So whenever we have to write work done, we should start with this minus times of P external into dV. If the process is reversible, then P external is continuously changing and it is always almost equal to P system. So for reversible process, we can write that work done in reversible process will be minus times of P system into dV. We can write like that because there is always a very small change in the P external and P system. When the process is irreversible, then we have to write this as P external only, right? So this thing you have to follow. Then see, हम जब केमिस्ट्री में देखेंगे एनसीईआरटी तो इन एनसीईआरटी वी आर राइटिंग फर्स्ट लॉ एज चेंज इन इंटरनल एनर्जी इज इक्वल टू क्यू प्लस डब्ल्यू यू हियर इज इंटरनल एनर्जी आई हैव रिटन इन फिजिक्स में अगर आप देखोगे तो फिजिक्स में ऐसा लिखा है डेल्टा ई इज इक्वल टू क्यू माइनस डब्ल्यू this is written in physics and this is written in chemistry ncrt we have to understand that both are correct. So this is European convention which is used in physics, and this capital E is total energy. Here in chemistry, we are using U, which is internal energy. So we should understand that what is the difference between total energy and internal energy, right? So when we are discussing here, capital E is macroscopic kinetic energy plus macroscopic potential energy plus internal energy. Macroscopic का क्या मतलब हुआ? Suppose we have a box in this ideal gas is there and the whole box is moving. So the kinetic energy of this box is macroscopic kinetic energy. Macroscopic potential energy means if the gravity is acting on this box, right? The gravity is acting on this box. So because of gravitational potential energy, it has macroscopic potential energy. Or suppose some gas particles are there and there is electric field. Again, there is macroscopic potential energy. So when we study physics, we are writing total energy because it includes macroscopic kinetic energy, box can move, or there is an effect of gravity. So that is macroscopic potential energy. But in chemistry, we are not studying this because our system is at rest. Means kinetic energy of this box will be zero. And there is no effect of external field on the system. These gas particles are moving. There is no effect of gravity on these gas particles. So macroscopic potential energy will be zero. So we are saying that in our case, since our system is at rest and there is no effect of external field, the total energy is equal to internal energy. So that's why in chemistry we write here internal energy and in physics we write total energy, right? So that is the difference between internal energy and total energy. For us, the system is at rest and there is no effect of external field. That's why the total energy and internal energy are equal. तो chemistry में हम first law को इस तरह से लिखते हैं, right? Now internal energy क्या क्या include करती है? It consists of molecular, translational, rotational, vibrational kinetic energy. It consists of electronic energy. Electronic energy means suppose we have helium atom, so there is electrostatic force of repulsion, so there is a potential energy which is positive between these two electrons. There is an electrostatic force of attraction between nucleus and electrons, so there is also potential energy. So these all type of potential energy include in internal energy. It consists of relativistic rest mass energy, right? Rest mass energy means mass can be converted into energy, that is E is equal to mc square, Einstein equation, right? It consists of potential energy due to interaction between the molecules. Suppose we are talking about gas molecule, helium gas molecules are there, so there can be repulsion or there can be attraction. So internal energy of the system include all type of molecular kinetic energy and all type of molecular interactions or electronic interactions. We cannot determine absolute value of internal energy of the system, but we can determine the change in internal energy. So this is also important. इसकी हम absolute value calculate नहीं कर सकते, but we are calculating the change in internal energy, right? So according to the first law of thermodynamics, energy of universe is constant. Energy of universe is energy of system plus energy of surrounding. And we are saying that in first law, energy of universe is constant, means change in energy of universe will be zero for any process. So for any process, we can say that the change in internal energy of the system or total energy of the system is minus times the change in total energy of the surrounding. So in our case, I should write that change in internal energy of the system is minus times of change in internal energy of the surrounding. Internal energy, because in first law there are three terms: internal energy, work energy, and heat energy. We have to study one by one about them. So we are discussing first with internal energy of the system. Our system can be an ideal gas, real gas, solid, and liquid. So we are starting with an ideal gas. We cannot determine the absolute value of internal energy of an ideal gas during expansion and compression of an ideal gas. Suppose this is an ideal gas and we are suppose the piston is moving in outward direction or inward direction. So what is going to happen when this is ideal gas? There is no interactive forces, so there is no change in potential energy of the system when expansion and compression is taking place. Neither this potential energy due to force of attraction between nucleus and electrons or due to repulsion between electrons, none of the potential energy is going to vary. So an ideal gas participating in expansion and compression, the change in potential energy is always zero. So we can say that change in internal energy is equal to change in kinetic energy. And kinetic energy, we know that it depends on temperature. That's why we say that if an ideal gas participating in any process, the change in internal energy only depends in change in temperature, right? So there are three types of kinetic energy: translational, rotational, and vibrational. For an ideal gas, gas can be monatomic, diatomic, polyatomic. There are three translational degree of freedom, right? So when we are talking about translational degree of freedom, suppose the gas is monatomic, so the center of mass of the gas and the geometric center will coincide. But if it is diatomic, the center of mass of the system is different, right? Here, this is the center of mass of the system. In translational motion, only central of mass of the system is going to move. So it can change its x, y, and z coordinates. That's why the degree of freedom for translational degree of freedom for any molecule, like either it is monatomic, diatomic, polyatomic, it is going to be 3 because center of mass ka movement hai. When we are discussing about a linear gas and we are discussing about rotational degree of freedom, for a linear gas, there is only two rotational degree of freedom, because if I rotate the gas particle along the axis, right, then the rotational degree of freedom will be zero, because we can say that the value of R will be very small, right? So when we write this, rotational kinetic energy is equal to half I omega square. I is directly proportional to mr square because of a small mass, and R value is very small along this line. So because of that, we'll say that because of this along the line, center of mass line, we can say this line, there is no contribution to kinetic energy, but perpendicular to that there will be two. So because of that, we'll say the degree of freedom will be 2. In non-linear molecule, we know that degree of freedom will be 3, right? So like CH4 molecule, there are total 5 atoms, and each atom can change its coordinate. For this atom, there is coordinate x1, y1, and z1. For all these atoms, there are 3 coordinates, and these coordinates can be changed, right? So when we are saying that there are 5 atoms, the total degree of freedom when we write that is equal to number of atoms, and each atom has 3 degree of freedom. So total degree of freedom should be 15. When we are talking about translational degree of freedom, this is total degree of freedom. Translational degree of freedom is equal to 3 because it is related to center of mass. Then rotational, this is a non-linear molecule, so we can say that the rotational degree of freedom will be 3. And if I have to calculate vibrational degree of freedom, total में से हम इन दोनों को minus कर देते हैं, so from there we'll say that the vibrational degree of freedom will be 9. So this is a way to calculate the different type of degree of freedom. So in this way, you can calculate different type of degree of freedom. So we can say that vibrational degree of freedom in a linear molecule will be 3n minus 5, where n is the number of atoms in the molecule. And for non-linear, it is 3n minus 6. So I will share all these things. You can at low temperature. This point is important because based on this, there is a question in JEE Advanced. जैसे आप फिजिक्स में जनरली एक आप फॉर्मूला पढ़ते हो, है ना, डिग्री ऑफ फ्रीडम से रिलेटेड, और आई थिंक गामा और डिग्री ऑफ जो भी है सीपीसीवी और गामा से रिलेटेड कुछ फॉर्मूला पढ़ते हो, जिसमें आप वो गामा की वैल्यू डायरेक्ट यूज करते हो. व्हाट इज द फॉर्मूला यू यूज इन फिजिक्स फॉर डिग्री ऑफ फ्रीडम एंड गामा रिलेशन? कुछ ऐसा होता है कुछ? सीपी और गामा और सीवी और गामा में रिलेशन कुछ होता है क्या? एनीवन? ओके. So this is important, that when we are generally talking in general, for most of the molecules, we are studying at moderate conditions. At moderate conditions of temperature and pressure, there are only two types of degree of freedom which are active. One is translational and other is rotational. When the temperature is very low, only translational degree of freedom is going to be active, and under drastic condition all the three type of degree of freedom is active. Drastic means at high temperature condition. Now this high temperature condition will also depend on the type of gas. If you read NCERT physics, they have mentioned that for certain gases at room temperature also the vibrational degree of freedom is active, but we cannot determine without doing the experiment. So we will use a general law. If nothing is mentioned, we are doing experiment at moderate temperature where translational and rotational degree of freedom is active. But J advanced में chemistry में they want to know that that with changing the temperature, the degree of freedom is going to change. That is an important point, right? So in physics, you study the law of equipartition of energy, that contribution of translational degree of freedom per molecule is RT by 2 per molecule per mole है, and this is per molecule. Avogadro number से divide कर दो kT by 2. For rotational it is RT by 2, for vibrational it is RT, right? So these things you already know. So an ideal gas participating in any expansion and compression process, we can write that total change in internal energy is total change in kinetic energy, and we can write that total translational kinetic energy, total change in rotational and vibrational kinetic energy. And if we simplify, we are getting that the net change in internal energy is equal to N, and this value, this whole value is equal to CV, N CV delta T. So whenever we are writing CV in chemistry, we consider all the three, right? If nothing is mentioned about temperature, then we consider translational and rotational. But if it is mentioned, then we have to consider all. So we should know that CV is equal to translational degree of freedom into R by 2, rotational degree of freedom into R by 2, and vibrational degree of freedom into R. So be careful about the language in the question. If nothing is mentioned, then we'll take only these two. For monoatomic gas, if we talking about monoatomic gas, only translational degree of freedom is there. For diatomic gas, translational and rotational under normal condition will be there. If drastic condition is there, vibrational degree of freedom will also be active, right? So we can say that the value of CV will depend on temperature, and we know that for ideal gas Cp minus Cv is equal to R. So we can say that the value of Cp for an ideal gas also depends on temperature, and the value of gamma, which is Cp by Cv, is also dependent on temperature, right? For monoatomic gas, only translational degree of freedom is active. There is no contribution of rotation and vibration. So we can say that for monoatomic gas, Cp, Cv, and gamma is independent of temperature. So these are very important points while solving the answers. तो ये मैंने यहाँ पे proof लिखा है कि ideal gas participating in any process. If an ideal gas participates in any process, we can prove that du is always NCV dt, right? So proof अभी इस टाइम पे आप देख लेना, but I am saying that ideal gas participating in any process, adiabatic, isobaric, isothermal, right? We always say that for a small change du is NCV dt, and dH we can write that is equal to NCP dt. So this is true for ideal gas participating in any process, right? So already you know about that, we have discussed, you can go through it, right? So there is a question I want to discuss which is asked in JEE Advance. So this is a very बहुत पहले पूछा गया क्वेश्चन है JEE Advance में. The molar heat capacity of helium gas at constant volume is always fixed, but the molar heat capacity of hydrogen gas at constant volume is less than 5 R by 2 at low temperature, 5 R by 2 at moderate temperature, and greater than 5 R by 2 at higher temperature, and becomes again 3 R by 2 on further increasing the temperature. Explain in 2-3 lines. So helium gas is a monoatomic gas, and we know that for monoatomic gas, there is only translational degree of freedom which is active at all temperature. That's why when we are writing that what is CV for monoatomic gas, translational degree of freedom into contribution, that is R by 2. When we are discussing what is Cp, that is equal to 5 R by 2, and we can write that gamma will be 5 by 3, right? So this is the value, and it is independent of temperature, because for monoatomic gas only translational degree of freedom is active. When we are talking about hydrogen gas at low temperature, when the temperature is very low, only translational degree of freedom will be active, and that is 2. That's why the value of CV is equal to 3R/2. When we come to moderate temperature, then rotational degree will also active. So rotational degree of freedom for diatomic molecule will be 2. So we can write here that 3 into R/2. This is for translational degree of freedom, and rotational degree of freedom will be 2. So 2 into R/2. So we can write that what is the value of CV. Then on further increasing the temperature, when we are saying that at high temperature, when translational degree of freedom is also active, we can find out that the total degree of freedom is equal to 3 into n की value 2 है. So total degree of freedom is 6. Translational degree of freedom will be 3. Rotational degree of freedom will be 2, means vibrational degree of freedom will be 1. So from here we can write that the value of CV at very high temperature will be 3R/2 plus 2R/2 plus R, because contribution here is R and there is 1 vibrational degree of freedom. Again, if I increase the temperature, the bond between hydrogen and hydrogen molecule is going to break and it will become monoatomic gas. That's why on further increasing the temperature, it becomes monoatomic. So CV value will be 3R/2. So you can go through this explanation, right? So this is a advanced question. इंटरनल एनर्जी ऑफ सॉलिड लिक्विड एंड गैस. अभी तक हमने पढ़ा कि फॉर एन आइडियल गैस द चेंज इन इंटरनल एनर्जी ओनली डिपेंड्स ऑन टेम्परेचर. इफ टेम्परेचर इज कांस्टेंट, देयर इज नो चेंज इन इंटरनल एनर्जी. We are assuming that we are not changing the number of moles of the system. If we change, because internal energy is an extensive variable, if you change the moles, definitely internal energy will change. So for a fixed amount of the substance, we are talking that on changing the temperature, how it is going to change. Now, for solid, liquid and real gas, we are talking, suppose we are talking about boiling of water. So H2O in liquid state at 1 atm 373 Kelvin is converted into H2 in gaseous state at 1 atm and 373.1. So this is normal boiling point of water. The average kinetic energy means kinetic energy per molecule only depends on temperature. It is independent of state of matter. Either it is in liquid state or in gaseous state or in solid state. Average kinetic energy of any substance only depends on temperature. It is independent of state of matter. So here when we are talking about average kinetic energy of water in liquid state at 300 degrees Celsius, and average kinetic energy of water in vapor state at 100 degrees Celsius, both will be same. That's why the change in kinetic energy during this phase transition is equal to 0. So you should understand that why the change in kinetic energy is equal to 0, because this point average kinetic energy does not depend on state of matter, it only depends on temperature. Now internal energy of the system is kinetic energy plus potential energy. Change in internal energy is change in kinetic plus change in potential. Change in kinetic energy is 0 for this phase transition because temperature is constant. So change in internal energy is equal to change in potential energy. Now we know that if the water is in liquid state, the force of attraction will be more between water molecules with respect to gaseous state. Here the molecules are far apart, here the molecules are nearby, and force of attraction means potential energy will be negative. So here more negative potential energy will be there. Here also force of attraction is there, so potential energy is negative here. But suppose this potential energy is minus 100 unit, so this potential energy will be minus, I am writing any arbitrary value, minus 60. So more force of attraction, so here potential energy is less and here potential energy is more. So we can say that the change in internal energy is equal to change in potential energy, and change in potential energy is positive, right? You can also understand that we are giving heat energy to the system in order to boil it. If this is the system, I am giving heat energy. So what should happen on giving heat energy to the system? The internal energy of the system should increase. So here the internal energy is increasing, and this internal energy is increasing due to increase in potential energy. There is no change in kinetic energy. So these are the very important points they can ask. They can ask that what is the molar heat capacity or heat capacity of this system. Heat capacity is defined as amount of heat required to raise the temperature by 1 degree Celsius, right? So heat capacity, if we see here, there is no change in temperature. So heat capacity will be infinite. For such system where temperature is constant, heat capacity is equal to infinity. So if we are discussing about this phase transition, suppose here the substance is existing in solid state and we are giving heat energy to the system. So on giving heat energy to the system, here there is a change in kinetic energy because temperature is rising. When we are giving heat energy to a solid and the temperature of the solid is increases, there is change in potential energy as well as kinetic energy. But when there is a phase transition, when this solid is going to melt, there is no change in kinetic energy of the system. Only the potential energy of the system is going to increase. Again here, this is heating of liquid. In heating of liquid, temperature is going to increase, so kinetic energy is going to increase. Potential energy, because on heating generally the molecules will be far apart, so we can say that potential energy is also going to increase. But here when boiling is taking place, the temperature is constant, so change in kinetic energy will be zero. The change in internal energy is equal to change in potential energy, which is equal to positive. So these are the things related to phase transition. Same way you can write for melting of solid. For melting of solid, again, temperature is constant, so there is no change in kinetic energy. Change in internal energy is equal to change in potential energy, and potential energy of liquid is more than solid because here force of attraction will be more and here force of attraction will be more. Less potential energy is always looked with sign, so here sign will be more and more negative and here less negative, so change in potential energy will be positive. Same way you can go for sublimation. I will share all these things, right? Triple point में भी आप इसी तरह से explain कर सकते हो. Now this is a question. Calculate the molar change in internal energy for a van der Waals gas going from state 1 to state 2. They have given temperature and volume. CV of the gas is given. This is a van der Waals gas जिसका CV दे रखा है. And A is given. A is van der Waals constant, which is also given. A is given. There is they have not given the value of B, means we have to neglect B. So first thing is that we understood that the internal energy of an ideal gas, when we are talking about ideal gas, internal energy of ideal gas only depends on temperature, and we can always write that du is equal to ncv dt. Ideal gas participating in any process, the change in internal energy is equal to ncv dt. But when we are talking about internal energy change of solid, liquid and real gas, internal energy is a state variable. So change in internal energy can be written as a function of volume and temperature. So since internal energy is a state variable, I can write that the net change in internal energy is partial change in internal energy with respect to volume when temperature is constant into dV, partial change in internal energy with respect to temperature when volume is constant into dt. So we are saying that for ideal gas, internal energy only depends on temperature. If temperature is constant, this whole term is zero. And we are saying that this change in internal energy with respect to temperature at constant volume, by using first law of thermodynamics, we can write that delta U is equal to Q plus W. When volume is constant, work done will be zero. This is expansion compression work. So we can write that delta U is equal to QV. And we know that QV is equal to NCV delta T, right? Or for a small change, we can write that du is equal to del QV, and that is equal to NCV dt. So from here, we can write that du upon dt at constant volume is equal to N into CV. And that's why this is derived by using this equation. Now for van der Waals real gas, if we are talking, or for solid liquid, right, all the substances, for all the substances, this formula is valid. If volume is constant, du is equal to ncv dt. So du upon dt at constant volume is N into Cv. So I can put this for solid, liquid and van der Waals real gas. For all, I can use this equation. I can write that change in internal energy is equal to partial change in internal energy with respect to volume and temperature is constant into dV plus this ncv dt. This is valid for solid, liquid and real gas. यहाँ तक valid है. Now this equation is not in our syllabus. अपने syllabus में नहीं है, right? So agar they are going to ask a question, they will give this Maxwell equation so that we can derive this value. So if we derive this value will come n square a upon v square this value, right, into dV plus n CV dt. So this is the change in internal energy of van der Waal real gas. And now from this, we can ask questions. Suppose they are saying that isothermal process is there. So for asking question, they have to mention this. Without this, they cannot ask the question. So isothermal process is there. For isothermal process, you can write that van der Waal real gas undergoing isothermal process, this is going to be 0. So in isothermal processes, expansion is taking place. N square A and V square, this is positive. Expansion में change in volume will be positive. So we'll say that internal energy of the van der Waal real gas is going to increase. Or if we say that there is compression of van der Waal real gas, from there we can say that the change in internal energy is going to decrease. So for an ideal gas, the change in internal energy only depends on change in temperature. But for solid, liquid and real gas, the change in internal energy will depend on temperature as well as pressure and volume. Here you can see volume, right? So we can say that for solid, liquid and van der Waal real gas, or solid or liquid, the internal energy is also a function of state of matter, right? And temperature both. State of matter means pressure, volume and temperature, we can say. So that is a point. We have solved the question. You can go through it. So based on the same, they have given the data, and now by putting the data, you can solve the question, right? Calculate the molar internal energy for van der Waal gas undergoing state 1 to state 2. So for van der Waal gas, you should know that this value is equal to n square A upon V square, right? So after that, you can solve this question. There is nothing in this question, right? So these are all related to that only what I have explained. Moving next, enthalpy. So enthalpy is a state variable. We know that exchange of heat energy between system and surrounding at constant volume can be measured in terms of state variable, that is change in delta U. QV को हम लिखते हैं delta U. And most of time when we do experiment, pressure is constant. So we want to write the exchange of heat energy at constant pressure in terms of a state variable. And for that, we have derived this enthalpy. So because of this reason, because most of the reaction is taking place at constant pressure, we want to write the exchange of heat energy in terms of a state variable. Right? This is about bomb calorimeter, means volume is constant. So most of chemical reactions or physical processes are carried out at constant pressure. We need to define another state variable which may be suitable under this condition. The exchange of heat energy at constant pressure can be measured with the help of change in state known as enthalpy. And enthalpy can be written as internal energy plus pressure volume energy. So we can use first law of thermodynamics to prove that if a solid, liquid, gas, the gas may be ideal or real, is participating in isobaric process by using first law of thermodynamics and by using H is equal to U plus PV. If H is equal to U plus PV for isobaric process, we can write DH is DU plus PdV. And by using first law of thermodynamics, the heat energy exchange at constant pressure can be written as DU plus PdV. And if we equate, we can say that a solid, liquid and gas participating in any isobaric process, we can say that QP is equal to delta H. So this is valid for solid, liquid, gas, chemical reaction, all the things, that at constant pressure exchange of heat energy is equal to change in enthalpy of the system. Right, this is okay. So we have already discussed that an ideal gas participating in any process, change in internal energy only depends on temperature. Du is NCV dt. Similarly, we can prove that change in enthalpy only depends on temperature. DH is NCP dt. But for a solid, liquid and real gas, it also depends on a state of matter and chemical composition, right? So here prove that at constant pressure delta H is equal to QP is valid for solid, liquid and gas. तो एक तरीका तो अभी हमने प्रूव किया, ये दूसरा तरीका है कि enthalpy is a function of pressure and temperature. It is a state variable. So net change in enthalpy is equal to partial change in enthalpy with respect to pressure when temperature is constant into dP plus partial change in enthalpy with respect to temperature when pressure is constant into dt. Now isobaric process में pressure is constant, so dP is equal to this term, whole term will be 0. So we can write that dH is equal to dH upon dt, at constant pressure into dt. And by using first law of thermodynamics, we can prove that dH upon dt at constant pressure is n into Cp. So n Cp dt, right? So this is valid for all. This is valid for solid, liquid, gas, right? We have proved that for an process in which pressure is constant, change in enthalpy is equal to n Cp dt. But for an ideal gas, जरूरी नहीं है कि प्रेशर कांस्टेंट है. फॉर एन आइडियल गैस, आइसोबेरिक, आइसोकोरिक, आइसोथर्मल, कोई भी प्रोसेस हो, फॉर एन आइडियल गैस DH is always NCPDT. So that is a difference between solid, liquid, and gas and an ideal gas. So these things are there. You can go through it. Enthalpy of solid, liquid, and gas. Suppose we are discussing about melting of ice, and we know that this is an endothermic process. In order to melt ice, we have to give heat energy. So we know that QP is positive, and we know that QP is delta H. So from here, we can say that enthalpy of liquid is greater than enthalpy of solid. So if they are asking what is the relation between or what are the different things which we can say about this process, we have already discussed that temperature is constant. So change in kinetic energy will be zero. Change in internal energy is change in kinetic energy plus change in potential energy. Change in kinetic energy is zero. So change in potential energy is change in internal energy is equal to change in potential energy. And we know that potential energy of H2 in liquid state is more. We are talking with sign. So इसका magnitude कम है but sign negative है. So we are saying potential energy of water in liquid state at this condition will be greater than potential energy of water in solid state at these conditions, right? So delta U will be positive. Delta H और U का relation we know that H is equal to U plus PV. And here when this melting is taking place, pressure is constant. So we can write that delta H is equal to delta U plus P delta V because pressure is constant. So from here we know that आइस का वॉल्यूम ज्यादा है और लिक्विड स्टेट वाटर का वॉल्यूम कम है. सो दिस डेल्टा वी इज गोइंग टू बी नेगेटिव. So this is positive, and this is negative. So from there we can exactly say that delta H is greater than less than delta U. ये क्वेश्चन पूछा जाता है कि when melting of ice is going to take place, which relation is correct? So change in enthalpy here is less than change in internal energy. अगर प्रैक्टिकली बात करें तो चेंज इन वॉल्यूम इज वेरी स्मॉल. तो इसको अगर हम नेग्लेक्ट करेंगे, अप्रोक्सीमेशन लेंगे, तो वी कैन से delta H is approximately equals to delta U. But exactly talking, delta H is less than delta U because here P delta V is going to be negative. Right? सेम वे यू कैन डिस्कस अबाउट बॉलिंग. बॉलिंग में थोड़ा सा आपको ध्यान रखना है डेल्टा एच और डेल्टा यू में, बिकॉज हियर द वॉल्यूम इज मोर एंड हियर द वॉल्यूम इज लेस. सो अगेन वी आर यूजिंग द रिलेशन डेल्टा एच इज इक्वल टू डेल्टा यू प्लस pressure is constant while boiling is taking place. So P delta V is positive here. Internal energy change is equal to potential energy change, which is positive, and we are giving heat energy. So QP is delta S. So this is also positive. So we can say here that delta H is greater than delta U, right? You can say same thing, same concepts are there. You can write, right? So relation between enthalpy and internal energy change. I want to discuss some important points क्योंकि JEE एडवांस में बहुत सारे सवाल इस पे पूछे गए हैं. H is equal to U plus PV, right? This is valid for all solid, liquid, gas, chemical reaction. सबके लिए ये valid formula है. Now, if I am saying that a chemical reaction is there, suppose if I am writing that nitrogen plus 3 times of hydrogen is giving 2 times of ammonia, and these all are gases, and they have given that these gases are have deviation from ideal behavior, means they are acting like real gas. If they are acting like real gas, then we have to write the relation. We can say that delta H is equal to delta U P2 V2 minus P1 V1. Suppose this reaction is taking place at constant pressure and temperature. So we'll say that the initial volume of the system will be something and final volume of the system when this reaction will be completed will be something. Pressure and temperature is constant, right? But if this is real gas, we cannot write delta H is equal to delta U plus delta NGRT. You should understand that ये कब आएगा? When we are saying here that pressure is constant, I can write for real gas also, I can write that P final volume minus initial volume. But if this gas is behaving like an ideal gas, अगर ये गैस आइडियल गैस की तरह बिहेव कर रही है, then I can write ideal gas equation P delta V is equal to delta NGRT. तो बी केयरफुल, कई लोग जो है ना बस केवल फॉर्मूला याद रखते हैं, कई बार दे विल गिव द टेम्परेचर, दे विल provoke you, they will say that gas is real, temperature is this, initial pressure is fixed, volume is changed, right? If it is taking place at constant pressure and temperature, what is the relation between delta H and delta U? This अगर आप ये लिख रहे हो मतलब you are assuming that the gas is ideal, right? So be careful about that. Most of the time they are asking the same thing, right? So this relation is valid for solid, liquid, gas, right? Chemical reaction, it is valid for all. So based on that, matlab chemical reactions, when you are studying, either the reaction is taking place at constant pressure or temperature, or the reaction is taking place at constant volume and temperature. When the same reaction is taking place at constant volume and temperature, in the same way you can write the relation. Here you have to write delta H is equal to delta U, plus अगर वॉल्यूम कांस्टेंट है तो यू कैन राइट वॉल्यूम इज कांस्टेंट एंड P2 minus P1, P final minus P initial, you can write like this. If this is a real gas, right, then this is fine. If it is an ideal gas, then it can be further modified. अगर ये ideal gas है, then I can write delta H is equal to delta U, और V delta P को हम लिख सकते हैं delta NGRT, right? So this is valid. जब भी delta NGRT आप use कर रहे हो, this is not used for real gas. It can be used only for ideal gas. That is the important point. So again, the same concept I have explained. Let us go directly to the question. So the first question of JEE Advanced, देखो इसमें 3-4 बार question JEE Advanced में पूछेंगे. They are very simple question. 1 mole of non-ideal gas undergo a change in state from this to this, right? Where pressure, volume, temperature, all things are changing. The change in internal energy is given. What is the change in enthalpy? So what we have to do, non-ideal gas, we should write delta H is equal to delta U, right? Plus P2 V2 minus P1 V1. I have to write like this, right? And we can write that delta H delta U is given. This is a very simple question. P2 V2, फाइनल प्रेशर एंड वॉल्यूम का मल्टीप्लीकेशन जो है वो 20 है, इनिशियल प्रेशर एंड वॉल्यूम का मल्टीप्लीकेशन जो है दैट विल बी 6. यू कैन सिंप्लीफाई, सो दिस इज 44. ऑल ऑफ यू नो अबाउट दैट, बट रीड द क्वेश्चन केयरफुली. Then the second question, for the reaction, this is the reaction, delta H of the reaction is given. In 1 liter vessel at 500 Kelvin, the initial pressure is 70 atm, and after the reaction, it becomes 40 atm at constant volume of 1 liter. Calculate the change in internal energy. All the above gases shows a significant deviation. तो यहाँ टेम्परेचर दे रखा है. कुछ लोग जो है, मोस्ट ऑफ यू, अगर आप ध्यान से नहीं तो क्योंकि टेम्परेचर गिवन है, डेल्टा एनजी पता है, यू विल गो बाय दिस. दिस इज रॉन्ग. दिस इज पॉसिबल. when the gases are behaving idly, you have to write delta H is equal to delta U. Here volume is constant, so final pressure minus initial pressure. So delta H की वैल्यू दे रखी है minus 560 किलो जूल पर मोल. You have to write this delta U in kilojoule per mole. They have given this 1 liter ATM is 0.1 kilojoule. So volume is 1 liter and pressure change final minus initial. Final is 40, initial is 70, so minus 30 liter ATM. Convert into kilojoule, so 0.1 से इसको आप multiply कर दो. So you can further simplify, right? This is minus 560 और ये minus इधर जाएगा, plus हो जाएगा plus 3. So this is 5 minus 557. You can calculate the internal energy change. So ध्यान से आप क्वेश्चन को पढ़ो. This is also a very good question. 1 mole of a liquid at 1 bar and 100 ml is taken in an adiabatic container and the pressure increases steeply to 100 bar. So initially we have a liquid. Suppose we are saying A, which is in liquid state. इसका 1 mole है, pressure is 1 bar and इसका volume जो है इस liquid का 100 ml है. And this whole liquid is taken in an adiabatic container. So this container is adiabatic, means Q exchange will be 0. the pressure is steeply increased. Suddenly the pressure on a liquid, ये liquid state में ही है, 1 मोल ही है, बट प्रेशर स्टीपली जो है वो 100 बार कर दिया गया है. अचानक इसका प्रेशर चेंज कर दिया है. जब इसका प्रेशर बढ़ाया है, initially the volume is not going to change. When you maintain the same pressure for some time, then this a liquid will decrease its volume, and at 100 bar it will become 90, decrease by 1 ml, it will become 99 ml. So पहले तो आपको ये स्टेट की तरह लिखना है कि ये पहला स्टेट है, ये दूसरा स्टेट है, एंड दिस इज थर्ड स्टेट. जैसे ही हमने प्रेशर बढ़ा वैसे ही वॉल्यूम कम नहीं होगा, इट विल टेक सम टाइम. And the whole thing is taking place in adiabatic container. For the whole system, Q will be 0. So change in internal energy is equal to work done. Here there is no change in volume, so work done will be 0. Here volume, work done क्या लिखेंगे, dw is minus times of P external into dv, right? So pressure is constant, so P external is equal to pressure of, ये P external ये 100 bar, so minus times of 100 bar, and volume change हमें लीटर में लिखना है. So 1 ml का volume change is negative, so if we put in liter, I have to divide it by 1000. So we can say that the work done, because यहाँ पे वॉल्यूम डिक्रीज करा, वर्क डन विल बी पॉजिटिव 1/10 लीटर एटीएम में ये वर्क डन हो गया. फॉर दिस होल प्रोसेस डेल्टा यू इज W and W total is this plus this. So we can say that the change in internal energy for the whole system is 1/10 liter ATM. Now I have to calculate what is the enthalpy change for the whole system. Enthalpy change will be internal energy change plus P final V final minus P initial V initial. So from here delta U की वैल्यू है 1/10 लीटर एटीएम में, P final की वैल्यू it becomes 100 and final volume becomes 99. So 99 divided by 1000, ये लीटर में हो गया, minus initial pressure was 1, volume is 100 ml, so 100 divided by 1000. So this will cancel out. So we can say here that finally the enthalpy change is equal to 9.9 liter ATM. So again, this question was asked. Read the question carefully, right? There are many questions asked between the relation of delta H and delta U. So this is very important for us. Now, first law of thermodynamics में we have studied about internal energy. Now we are studying about Q and W. So Q की अगर हम बात करते हैं, Q and W are not energy, it is mode of transfer of energy. जैसे अगर आप हो तो आपके अंदर अभी आपसे पूछा जाए कि आपके पास कितनी हीट एनर्जी है, you cannot say. When you move from here to here, some part of your internal energy will converted into heat energy, but at a particular state you don't have heat energy, you don't have work energy. So we say that heat and work is not energy, they are mode of transfer of energy. So heat energy, it is an extensive variable, path variable, it is a random form of energy. Because अगर एक मास है, बॉल है यहाँ पे, और मैंने इसको 10 किलो कैलोरी हीट एनर्जी दे दी, 10 किलो कैलोरी हीट एनर्जी दे दी, इट विल डिसिपेट दैट हीट एनर्जी इन ऑल डायरेक्शन. रैंडमली वो अपनी हीट एनर्जी को डिसिपेट कर देगा. दैट्स व्हाई इट इज अ रैंडम फॉर्म ऑफ एनर्जी. जबकि यही बॉल है और इसको मैं वर्क एनर्जी प्रोवाइड करूंगा. सपोज आई एम पुशिंग दिस, तो ये बॉल एक पर्टिकुलर डायरेक्शन में मूव कर रही है. दिस इज अ रेगुलर फॉर्म ऑफ एनर्जी. वर्क इज रेगुलर एंड हीट इज रैंडम फॉर्म ऑफ एनर्जी. डेल्टा किसी भी सब्सटेंस, चाहे वो सॉलिड हो, लिक्विड हो, गैस हो, अगर वॉल्यूम कांस्टेंट है देन वी कैन राइट दैट डेल्टा क्यूवी इज इक्वल टू, वर्क डन 0 होगा. फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, डेल्टा क्यूवी इज डी यू and that can be written as ncv dt. From here I can say that change in internal energy with respect to temperature at constant volume is equal to n into cv. This is heat capacity at constant volume, right? This is valid for solid, liquid and gas. Similarly, when pressure is constant, we can say that change in enthalpy with respect to temperature at constant pressure is heat capacity at constant pressure. This is also valid for solid, liquid and gas. Now when we are relating entropy, entropy को हम कैसे define करते हैं? Entropy change is dq reversible upon T. So dq reversible is TdS. Temperature in Kelvin is always positive. So the sign of heat energy in a reversible process can be predicted with the sign of entropy change. If entropy change is positive, we'll say that heat is given to the system. If entropy change is negative, we say that heat is given by the system. जैसे हम वर्क के लिए भी ऐसा ही लिखते हैं ना कि dw is equal to minus times of P external into dV. So if the pressure is always positive, if the volume change is negative, we'll say that work is done by the system. When the volume change is volume change is positive, work is done by the system. When volume change is negative, we'll say work is done on the system. So be careful about this work IUPAC convention. हमें work is done on the system और done by the system वॉल्यूम चेंज से पता चलता है. वैसे ही रिवर्सिबल प्रोसेस में हीट एनर्जी का एक्सचेंज इंट्रोपी के एक्सचेंज से पता चलता है. इंट्रोपी चेंज पॉजिटिव, so heat is given to the system. Entropy change negative, so heat is rejected by the system. वर्क इज एक्सटेंसिव वेरिएबल, पाथ वेरिएबल. वर्क इज रेगुलर फॉर्म ऑफ एनर्जी. अभी मैंने समझाया कि वर्क रेगुलर कैसे है. जैसे अगर मान लो ये एक्सपेंशन हो रहा है, तो ऑल दीज पार्टिकल्स इन एटमॉस्फेयर विल मूव इन अ पर्टिकुलर डायरेक्शन, दैट इज अपवर्ड डायरेक्शन. सो दिस इज रेगुलर फॉर्म ऑफ एनर्जी. The IUPAC convention of expansion compression work I have already discussed. So for irreversible process, P external is constant. For reversible process, P external is almost equal to P system and both are variable. When isobaric process, then P external is equal to P system is constant. सो वर्क डन में हमें एक दो बातें याद रखनी है. यहाँ पे यही समझा गया है, तो मैं शॉर्ट में बता दूं कि वेन एवर वी आर डिस्कसिंग वर्क डन, राइट, सपोज वी आर पार्टिसिपेटिंग इन अ इरिवर्सिबल प्रोसेस, आइसोथर्मल इरिवर्सिबल प्रोसेस ले लेते हैं या कोई भी इरिवर्सिबल प्रोसेस. वी आर मूविंग फ्रॉम हियर टू हियर and we are writing dw is equal to minus times of P external into dV. When the process is irreversible, external pressure is constant. Irreversible process में external pressure जो है वो constant होता है. Suppose we are talking about a cylinder piston system having a gas. This gas is ideal and we are at initial state and the pressure of the gas is more. This is pressure of gas and this is P external. नाउ हियर देर इज अ, मतलब यहाँ पे कुछ है जो इसको एक वाल्व है जो इसको रोक रहा है. दिस इज द इनिशियल कंडीशन. जैसे इस वाल्व को हटाएंगे, दिस पिस्टन विल मूव फास्ट. वी आर अज्यूमिंग दैट इट इज मासलेस, तो ये यहाँ पे आके ये फाइनली रुक जाएगा. So in this whole process, the gas pressure is continuously decreasing, but external pressure is constant. So it is a irreversible process. तो जब भी हम किसी भी, चाहे वो सॉलिड हो, लिक्विड हो, गैस हो, इरिवर्सिबल प्रोसेस का वर्क डन लिखते हैं, तो विल राइट दैट पी इरिवर्सिबल इज माइनस टाइम्स ऑफ पी एक्सटर्नल. क्योंकि इसको हम इंटीग्रेट कर रहे हैं तो ये कांस्टेंट है. एंड इंटीग्रेशन ऑफ dv is equal to v final minus v initial, right? So this is the work done in an सिंगल स्टेप प्रोसेस और इरिवर्सिबल प्रोसेस. सपोज अगर मुझे यहां से दो स्टेप में मूव करना है, आई एम मूविंग फ्रॉम हियर टू हियर, आई विल मूव फ्रॉम ए टू बी एंड देन आई एम गोइंग टू मूव फ्रॉम बी टू सी. सेम थिंग है, यहाँ पे गैस का प्रेशर ज्यादा है, बट हियर एक्सटर्नल प्रेशर है, प्रेशर ड्यू टू एटमॉस्फेयर, और एक मास रखा हुआ है यहाँ पे. सो दिस इज द एक्सटर्नल प्रेशर. सो व्हाट विल हैपन, यहाँ पे अभी ये कुछ वाल्व लगा हुआ है, इसको मैं जैसे ही इसको हटाऊंगा, स्टॉपर लगा हुआ है, इस स्टॉपर को जैसे ही हटाऊंगा, दिस गैस प्रेशर इज मोर देन दीज टू, सो दिस विल मूव अप. यहाँ पे जाके ये रुक जाएगा. सो अगेन व्हाट विल आई विल डू, आई विल रिमूव द मास ओवर हियर. सो आई कैन से दैट नाउ there is only atmosphere pressure working. So finally what will happen, that this piston will go and stop here where pressure of gas final is equal to atmospheric pressure. तो यहाँ पे ये एक irreversible process हो गया जिसमें external pressure है P ATM plus pressure due to mass M. And this is also an irreversible process because here also pressure, external pressure is constant. So it is a sum of two irreversible process. इससे पहले क्या था कि pressure versus volume में हम A से B आ गए और फाइनली यहाँ पे जो गैस का प्रेशर और एक्सटर्नल प्रेशर बराबर है. सो वी आर सेइंग वर्क डन इज इक्वल टू दिस शेडेड एरिया. ये वाला जो एरिया होगा वो वर्क डन होगा. दिस इज वॉल्यूम चेंज वी फाइनल माइनस वी इनिशियल, और पी एक्सटर्नल यहाँ पे जो है वो प्रेशर ड्यू टू एटमॉस्फेयर ही है. दिस पी एक्सटर्नल इज प्रेशर ड्यू टू एटमॉस्फेयर. सो पी एक्सटर्नल वॉल्यूम चेंज, दिस इज द वर्क डन, राइट. अभी हम टू स्टेप प्रोसेस की अगर बात करेंगे तो वी आर मूविंग फ्रॉम ए टू बी एंड देन वी आर मूविंग बी टू सी. So when we are moving from A to B and finally when the piston will stop at point B, the pressure at point B is equal to pressure due to atmosphere plus pressure due to mass M, and the volume change will be this. So this is the work done. ये work done होगा. And when we move from here to here, we again say that the external pressure is constant, and here PC is equal to pressure due to atmosphere. और यहाँ से यहाँ तक ये A हो गया, ये B हो गया, and now this is C. B to C में ये volume change है. So this shaded area is equal to work done. So what is happening as we are increasing the number of steps, the work done by the gas is going to increase on increasing the number of steps, right? क्योंकि अगर मुझे अब इसमें 2 स्टेप की जगह 3 स्टेप में करना है, एक और मास रखना पड़ेगा. अगर रिवर्सिबल है तो नंबर ऑफ स्टेप्स इज इनफाइनाइट. So when any system, not gas, liquid, solid, any system, when it is expanding and it is expanding reversibly, in reversible expansion, the system will always feel maximum opposition from the surrounding, and that's why the work done by the system will be more when it is participating in reversible expansion, राइट. सिंगल स्टेप में वर्क डन कम होगा, मल्टीपल स्टेप में वर्क डन ज्यादा होगा. जैसे जैसे हम नंबर ऑफ स्टेप्स बढ़ाते जाएंगे, वर्क डन इज इक्वल टू एरिया अंडर प्रेशर वॉल्यूम कर्व, राइट. सो दैट इज अबाउट एक्सपेंशन वर्क डन. सो आई वांट टू से दैट कि आपको ये समझ में आना चाहिए कि चाहे वो सॉलिड हो, लिक्विड हो, रियल गैस हो, कुछ भी हो, इफ आई हैव टू से दैट expansion is taking place and this expansion is reversible, so we'll say that work done by the gas, magnitude की बात कर रहा हूं, work done by gas by system will be maximum. ये मैक्सिमम होगा. और इस केस में जब हम इस तरह से ग्राफ ड्रॉ करते हैं, बिकॉज इन रिवर्सिबल प्रोसेस देयर विल बी इनफाइनाइट पॉइंट्स, सो वी नो द ग्राफ, राइट. और एरिया अंडर द ग्राफ इज इक्वल टू द मैग्नीट्यूड ऑफ वर्क डन. Similarly, when we do compression, अगर हमें compression करना है, so in case of compression, when the process is irreversible, अगर process irreversible होगा, then work done on the gas will be on the system, work done on the system will be maximum. अगर हमें अचानक यहां से यहां मूव करना है, I have to move from here to here suddenly, so I will apply the pressure which I should apply here. क्योंकि मुझे डायरेक्ट यहां से यहां आना है, तो मुझे वो प्रेशर यहां अप्लाई करना पड़ेगा जो यहां होना चाहिए, तभी मैं यहां से यहां मूव करूंगा. अगर मुझे धीरे धीरे मूव करना है तो मुझे जो है वो कम वर्क करना पड़ेगा. सो दैट इज द डिफरेंस बिटवीन any system, right, solid, liquid and gas. Work done on the system when irreversible process is there will be maximum, and when expansion is there, work done by the system will be maximum when the expansion is reversible. So these two you have to understand, most of you understand that. So अब कोई भी हो, लिक्विड हो, कुछ भी हो, अगर आपको वर्क डन लिखना है तो आपको समझ में आना चाहिए कि वी शुड स्टार्ट फ्रॉम dw इज इक्वल टू माइनस टाइम्स ऑफ टी एक्सटर्नल इनटू dv, कुछ भी हो, राइट. वी कैन राइट नाउ हियर इट इज रिवर्सिबल, सो p एक्सटर्नल की जगह हम p सिस्टम लिखेंगे, राइट, इनटू dv. अब जैसे इस पर्टिकुलर केस में p सिस्टम की वैल्यू दे रखी है कि 10 प्लस 5v into dv, and then you can integrate and you will get the work done, right. So this is related to कैलकुलेट द वर्क डन. बाकी तो कैलकुलेशन है, आपको ये बेसिक्स का ध्यान रखना है. एप्लीकेशन ऑफ फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स इन डिफरेंट टाइप ऑफ प्रोसेसेस. तो पहला है आइसोथर्मल प्रोसेस. इस आइसोथर्मल प्रोसेस में हम दो तरह की चीजों के बारे में डिस्कस करेंगे. फर्स्ट वी डिस्कस अबाउट आइडियल गैस. सो ऑलरेडी वी नो दैट फॉर एन आइडियल गैस अगर टेम्परेचर कांस्टेंट है थ्रू आउट द प्रोसेस, if the initial and final temperature is same, the process may or may not be isothermal. Isothermal means throughout the process dt should be zero. ये सही है. Delta T should be zero does not indicate that the process is isothermal. dt is zero means at each and every point on this process, the change in temperature is going to be zero. So this is correct. So for an ideal gas, we know that ideal gas participating in any process, du is ncv dt, dt is zero, so this is zero, right? And from first law of thermodynamics, we can say that dq is minus times of dw. So we know that if heat is given to the system, this q will be positive, and the same amount of work is done by the system, so w will be negative, right? Magnitude बराबर होगा, because डेल्टा यू की वैल्यू जीरो है, और इफ वी आर कंप्रेसिंग द सिस्टम विल रिजेक्ट हीट एनर्जी. दिस इज फॉर एन आइडियल गैस. अगेन वी हैव डिस्कस्ड अबाउट वर्क, ये मैं समझा चुका हूँ. 2 स्टेप प्रोसेस, 3 स्टेप प्रोसेस, और ये रिवर्सिबल प्रोसेस के लिए वी कैन राइट लाइक दिस. दिस इज फॉर कंप्रेशन. वी हैव ऑलरेडी डिस्कस ऑल दीज थिंग्स, राइट. तो दिस इज अबाउट आइडियल गैस. अब देखिए आइडियल गैस से रिलेटेड जो जेईई एडवांस में क्वेश्चन पूछा गया है, वी डिस्कस दिस. An ideal gas is expanded from P1 V1 T1 to P2 V2 T2 under different conditions. The correct statement among the following is are: the work done on the gas is maximum when it is compressed irreversibly from P2 V2 to P1 V1, right, against a constant pressure P1. अगर अगेंस्ट अ कांस्टेंट प्रेशर P1 का क्या मतलब है? अगर हम एक्सपेंशन करें, द वर्क डन ऑन द गैस इज मैक्सिमम विट इज व्हेन इट इज कंप्रेस्ड इरिवर्सिबली फ्रॉम P2 V2. ओके, सही है. तो ये लिखा है कि यहाँ पे P2 V2 एक्सपेंशन के बाद है, और हम कंप्रेस कर रहे हैं, तो वी आर मूविंग टुवर्ड्स P1 V1 एंड टेम्परेचर इज कांस्टेंट है क्या? P2 V2 to P1 V1 against a constant external pressure. अगेंस्ट तो होना नहीं चाहिए ये, ठीक है. दिस इज करेक्ट ना? अगर हम कंप्रेस कर रहे हैं और इरिवर्सिबल कंप्रेशन करते हैं, तो ये कहने का मतलब कि यहाँ जो ये एक्सटर्नल प्रेशर लगाएंगे, वो शुरू से वो लगाएंगे जो यहाँ लगाना चाहिए, राइट. सो दिस सीम्स टू बी करेक्ट. द वर्क डन ऑन द गैस विल बी मैक्सिमम बिकॉज इट इज irreversible compression. This seems to be correct. If the gas is carried out freely, it is simultaneously both isothermal as well as adiabatic. तो ये जूल्स एक्सपेरिमेंट पे बेस्ड है क्वेश्चन. सो फ्री एक्सपेंशन का मतलब हो गया P एक्सटर्नल की वैल्यू जीरो है. सो इफ P एक्सटर्नल इज जीरो, वर्क डन विल बी जीरो. Q is zero is determined experimentally by Joule's experiment. By doing the experiment, we come to know that if there is a gas in a container and we are एक्सपेंडिंग दिस गैस इन वैक्यूम, तो यहाँ पे ये वैक्यूम है और यहाँ पे गैस है, आइडियल गैस है. तो इफ वी रिमूव और इसको हम एक वाटर टैब में रखते हैं और यहाँ थर्मोमीटर लगाते हैं, बाय डूइंग एक्सपेरिमेंट वी कम टू नो दैट Q विल बी जीरो. So if Q will be zero, W will be zero, so delta U will be zero. Then temperature will be constant. So we'll say that this free expansion is isothermal, irreversible, as well as adiabatic. So if expansion is carried out freely, it is simultaneously both isothermal as well as adiabatic. This is correct. This is true. The work done by the gas is less when expanded reversibly from V1 to V2 under adiabatic condition as compared to that when expanded reversibly from V1 to V2 under isothermal condition. So you know that we are starting here pressure versus volume graph. Initial state है, we are moving from initial state to final state. ये जो है वो आइसोथर्मल प्रोसेस है. दिस प्रोसेस विल बी आइसोथर्मल. और एडियाबेटिक में, because slope will be more for adiabatic, this will be adiabatic. So work done by the gas is area under curve. We say that we can say that the magnitude of work done in isothermal process will be greater than the magnitude of work done in adiabatic process. From graph you can directly say, graph आपको पता ही है. So this seems to be correct, right. ये when the gas, the work done is less दे रखा है. This seems to be correct. The change in internal energy of gas is zero if it is expanded reversibly with T1 is equal to T2. Yes, internal energy का change is equal to NCV dt and dt is zero. So this is zero. ये portion तो सही है यहाँ तक. Second part, positive. The change in internal energy is positive if it is expanded reversibly under adiabatic condition. But T1 is not equal to T2. अगर हम adiabatic process है, Q की value zero है, डेल्टा यू इज इक्वल टू डब्ल्यू, एक्सपेंशन में वर्क डन नेगेटिव होगा, चेंज इन इंटरनल एनर्जी नेगेटिव होगा, मतलब चेंज इन टेम्परेचर विल बी नेगेटिव, राइट. सो ये स्टेटमेंट फॉल्स है. दिस इज फॉल्स स्टेटमेंट, दैट्स व्हाई दिस इज फॉल्स. सो फॉर दिस द आंसर शुड बी एबीसी. एबीसी आंसर होना चाहिए इसका, राइट. दिस इज अ क्वेश्चन, वेरी गुड क्वेश्चन. मुझे बस केवल इसमें एक ट्रिक बतानी, बाकी आपको सब पता है. बस आई जस्ट वांट टू डिस्कस अ पॉइंट ओवर हियर. So they are saying that 1 mole of an ideal gas is taken from A to B along two paths denoted by solid and dashed lines as shown in the graph below. If the work done along the solid line path is Ws and that along the dotted path is W2, then the integer closest to WD upon Ws. ये जो है रिवर्सिबल है क्योंकि ग्राफ बना हुआ है. So for that I can write work done in isothermal reversible processes minus nRT V final minus V initial. Or I can write that minus nRT. nRT is equal to P into V. So P naught, V naught, initial pressure or volume जो भी हो, ln V final upon V initial. So if I put the value over here, ये जो है वो solid के लिए है. So W solid can be written as minus times of, यहाँ पे pressure 4 है, volume half है, तो PV will be 2 लीटर ATM में होगा. Ln V final is 55 and this is 0.5. So this is 11. 2 ln 11. इसको मैं अप्रोक्सीमेटली लिखना चाहूँ, ये इंटीजर टाइप है, सिंगल इंटीजर टाइप, तो ln 10 को मैं मान लेता हूँ 2.3. सो अप्रोक्सीमेटली दिस वैल्यू इज इक्वल टू -4.6 लीटर एटीएम में होगा. Now I am interested in this part. So जो dotted part है, for dotted part I am writing the work done. Work done from here to here, A to B I am writing. That is equal to minus times of pressure, यहाँ fix है, that is 4 into volume change. Volume का change जो है यहाँ पे 3/2 है. लीटर एटीएम में A से B आ गया, B से C वर्क डन 0 होगा, वॉल्यूम कांस्टेंट है. Then C to D. If I calculate what is the pressure over here, we know that कि यहाँ पे ये isothermal है, P1 V1 is 2 and here also at point C pressure volume is 2 and pressure is 1, तो this is also 2. तो यहाँ पे भी P into V will be constant. तो अगर यहाँ पे हमें वॉल्यूम पता है तो एट पॉइंट डी वी कैन से दैट P1 V1 is 2. So pressure at point D into volume is 3. So we can say that pressure at point D is equal to 2/3. So this is the point I want to discuss here. So if I want to write that what is the work done here, we should write यहाँ से यहाँ pressure 1 atm है. तो pressure is 1 atm and volume का change जो है वो 1 यूनिट से है, 1 लीटर से है. From D to E मान लेते हैं, इसको E कह लेते हैं. Now if I have to write pressure at point D is constant and that is equal to 2/3 and volume change you can write from here 5.5 और ये 3 है 2.5 आएगा, 5/2 आएगा. So now you can simplify, ये 2 और 2 cancel out हो गया. Here you can write that this is 2. So if you simplify, ये वैल्यू आ रही है -7 -5/3. So you can simplify this -7 और ये -1.8 आएगा, 1.6 आएगा ना. So 1.66, so -8.66. So now you can say that WD upon WS, और आपको इंटीजर लिखना है तो you can write -46 8.66 divided by -0.6. इसको सिंप्लीफाई करोगे नियर अबाउट ये 2 आएगा. So I was interested in this point, that how to calculate the pressure, right? एप्लीकेशन ऑफ फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, ये मैं क्वेश्चन समझा देता हूँ, ठीक है, आप ट्राई कर लेना, आंसर तो दे ही रखा. अ पिस्टन कैन फ्रीली मूव इनसाइड अ हॉरिजॉन्टल सिलेंडर क्लोज्ड from both ends. Initially the piston separates the inside space of the cylinder into two equal parts, each of volume V naught, in which an ideal gas is connected under the same pressure P naught and at the same temperature. What work has to be performed in order to increase isothermally the volume of one part of the gas eta times compared to the volume of other by slowing moving the piston. So it is isothermal रिवर्सिबल प्रोसेस. स्लोली मूविंग मीन्स आइसोथर्मल रिवर्सिबल प्रोसेस. तो क्वेश्चन यहाँ पे है, पहले दोनों का वॉल्यूम बराबर है, प्रेशर सेम है, सेम गैस है, नंबर ऑफ मोल सेम है. नाउ वी आर मूविंग दिस पिस्टन, तो यहाँ का वॉल्यूम ईटा टाइम्स इनिशियल वॉल्यूम हो गया, राइट. सो यू कैन कैलकुलेट दैट व्हाट इज, बिकॉज इन total volume will be conserved. 2V naught is equal to eta times of V plus V, right? And from there you will calculate what is the value V. And then you can apply the formula. Work done, यहाँ पे expansion हो रहा है, reversible expansion, और यहाँ पे reversible compression हो रहा है. Same formula you can apply and add them. So you'll get the answer, right? So you can try this question.
Sir,
Beta.
sir, could you, at the start of the lecture, you had explained the rotational degrees of freedom. Could you just explain that once again? Like how do we calculate?
बेटा रोटेशनल को कैलकुलेट करने के लिए यू नो व्हाट इज टोटल डिग्री ऑफ फ्रीडम. टोटल डिग्री ऑफ फ्रीडम इज इक्वल टू 3 times the number of atoms, and translational degree of freedom is always 3. Rotational will depend that molecule is linear or it is non-linear. If it is linear, rotational will be 2. If it is non-linear, rotational will be 3. So vibrational will be total minus F total minus F translational degree of freedom minus F rotational degree of freedom.
Okay. Thank you, sir.
So application of first law of thermodynamics during phase transition. तो मैं अभी एलोट्रोप्स वगैरह के बारे में बाद में डिस्कस करूंगा, बिकॉज व्हेन देयर इज अ क्वेश्चन मैच द कॉलम रिगार्डिंग एंट्रोपी चेंज एंड एंथैल्पी चेंज, दैट आई विल डिस्कस लेटर. बट यहाँ फेस ट्रांजिशन की बात हो रही है, राइट? सो वी कैन से दैट जैसे एलोट्रोपिक फॉर्म ऑफ कार्बन में फॉर्मूला विल बी सेम बट क्रिस्टलाइन स्ट्रक्चर विल बी डिफरेंट. दीज आर एलोट्रोप्स. एलोट्रोप वर्ड इज यूज फॉर एलिमेंट. These are two solids whose chemical composition is same but crystalline structure is different. I cannot say these are compounds. I cannot say they are allotropic form. We'll say this compound exists in polymorphic form. So there is a difference. Allotropes केवल हम element के लिए use करते हैं. We don't use the word allotrope for compound. Again, allotropes में formula अलग अलग हो सकता है. जैसे ozone O3 and O2, they are allotropic forms of oxygen. But nitrogen and nitrogen atom, they are not allotropic form. They are not allotropes. क्योंकि एलोट्रोपिक फॉर्म में क्या है कि एक ही एलिमेंट एक ही एटम दूसरे एटम से किस तरह से अटैच्ड है, अलग अलग तरीके से अटैच है. देन यहाँ पे कोई भी दूसरा एटम नहीं है. तो दिस एंड दिस, नाइट्रोजन एंड नेसेंट नाइट्रोजन, दे आर नॉट एलोट्रोप बट दीज टू आर एलोट्रोप्स. तो एलोट्रोप्स में फॉर्मूला अलग अलग हो सकता है, राइट? They are used for element, but this is not allotropic form. So melting of ice at its normal melting point. Now we are discussing all the.
सर वो डिनर करना था, वो खत्म हो जाएगा.
हाँ ठीक है फिर बेटा, मैं आज रोकता हूँ, फिर नेक्स्ट क्लास में देखता हूँ. ठीक है,
थैंक यू सर.
ओके.